Welcome back. Part 3 of our 3-part series on linear equations. If you've missed it, once again, I will probably link part 1 and part 2 at some point in the foreseeable future. But until then, please just access the playlist and watch those videos beforehand, because we are going to get a little dirty, diving deep into the trenches and trying to tackle these multi-step equations that can be a little intimidating when you begin. I'm going to start with 5a. And as I said before, I'm not going to do all of these. I put in a plethora, so that way you have some examples to work off of. But I will model a few of them and talk through the thought process and reasoning. So taking a look at 5a, right, we've got a lot of symbology. Okay, first and foremost, right, we see parentheses. Okay, parentheses must imply multiplication unless there's a symbol separating, and if there is, then they're just trying to trick you. Okay. So first and foremost, I want to alleviate myself of any type of grouping symbols. So we would want to distribute this 3 to both terms inside of the parentheses. If you forgot what distribution is just a nice fancy word of saying repeated multiplication to different terms. Okay, so I would want to distribute the 3 to the 2x, but using multiplication, right? So I'm going to do this on the side. 3 times 2x, that'll give me a 6x, and I will replicate that process. 3 times the 5 is positive, so that's going to give me positive 15 minus 10 equals 3x plus 10. Okay, step by step, play defense. All right, moving on to the next piece. Okay, notice, all right, so if you've watched part 2, right, we want to start collecting our components. On the left side, right, I can see a variable, and on the right side I see a variable. So I somehow need to group those two together, and I also see numerical values, sorry, not expressions, as well. Okay, but notice on the left side I've circled 2 numerical values. So what I actually want to do is I want to combine those first. Okay, since they're on the same side of the equation, I actually don't want to apply any type of opposite operations or inverse. I just want to merely do it, right? So I have to read this left to right. 6x variable plus 15 minus 10. 15 minus 10, I can simplify that to a positive 5, bringing it on the 6x. And 3x plus 10. Okay, and then once again, the cool thing, or the monotonous aspect of algebra, it's very redundant. Okay, we start off with completely unknown contexts, such as this one, right? We have grouping, we have multiple terms on each side of the equation, and as we continue to trim and trim, right, I like to cook, right? So as you're doing your prep, right, you're slicing off you know, the extra layer of fat that surrounds the steak. Okay, we eventually whittle down to the meat. So in this instance, right, 6x plus 5 equals 3x plus 10. We're going to kind of rinse and repeat the methodology that we've already been using. Okay, like I said before, I like to collect my variable terms on the left side of the equation. Okay, notice, or I notice, that my 2 variable expressions are 6x and 3x. So if I wanted to move my 3x from the right to the left, I would have to apply the opposite operation, which is subtraction, because it is positive, right? No symbol in front indicates positive. 6x minus 3x yields a 3x plus 5 equals, these canceled, right? 3x minus 3x will give you a 0 equals 10. Okay, should have probably wrote that up here. So I'm going to do so. 3x plus, not too shabby. And if you've watched the previous video, okay, I call this the windshield wiper effect, right? We moved this way, or sorry, to the left. So now I want to move back to the right, just like a windshield wiper. If your windshield wiper does not do that, please go see your mechanic. That way your windshield is clearer when you're driving in the rain. So as I'm moving a term back to the right side, notice this is the 10. This is the numerical value. So I wouldn't want to bring the 3x over. It doesn't really make sense. It's a variable. I can't combine terms that are variables and numbers. But I can bring the 5 over, right? And the 5 is currently positive 3x plus 5. So I'd want to subtract it in order to move it across. 3x equals 5. And last but not least, oh my goodness, we wind up with a fractional value. Get used to it, like I tell all of my adults. And if you are one of my adults watching, the underlying joke I always like to use with fractional values is I ask for your height. I'm 5'5", so technically I'm a fractional value. And if you're one of those people out there that think as soon as you get a fraction it's incorrect, then you, my friend, must be incorrect as well. But you're not. So fractions are never wrong answers. Okay, they can definitely be right answers. So here 5/3 is our value. And I'm not actually sure. I just kind of made up the future equations in my head as well. So best of luck with whatever the solutions may be. Let's proceed to another one. Let's take a look at J. Okay, perfect on timing. All right, so for J, that's a shape. There we go. Okay, notice the left side, 10x plus 12, two terms that are not like whatsoever. So we're going to pause there, right? Then we check the right side of the equation. We see another set of parentheses. Once again, we want to alleviate ourselves of any type of grouping symbols, and parentheses often indicate multiplication using the distributive property. So we're going to take this 2, and we're going to distribute it to both terms using multiplication. 2 times 5x will yield a 10x, and 2 times 6 will yield a 12. Once again, that's using the distributive property. Okay. Now, if you notice something, we have the left side, which is 10x plus 12, and the right side, which is 10x plus 12, and they're equal to each other. Okay. If we completed this process, and I'll allow you to do that on your own, you'll wind up, so long as you don't make any mistakes, at 0 equals 0, because all terms will cancel out with each other. And this is technically a true statement. So when we run into an equation like this, and it's not going to happen too often, but I want to make sure that you're prepared whenever you get ready to take your GED, your TASC, or your HiSET test. Okay, we would say that the solution to this equation is all real numbers. Okay, because essentially, right, since I'm left with a true statement, right, the variable is now gone, x is has been eliminated, but we're left with a true statement, right? 0 does in fact equal 0. We can technically substitute any number, right? Because if I substitute a 2 in for x, I'll have 10 times 2 plus 12 equals 10 times 2 plus 12, right? It'll be the same value because we have the same equation or same expression on the left and right side of the expression. Now, if I get two numerical values that are not equal, right? Let's say we simplify this and got 0 equals 1. That's not true, okay? And what that's informing us is that there are no values that would ever satisfy this equation, okay? So it's something to be mindful of, okay? So, and obviously I include it as a text, so let me type rather than write. When every number is a solution of the equation is called an identity. Come on, work with me. Inside. Let's move you. All right, you want to be difficult. Stay there. These can be found when both sides of the equation equal. There you go. Now we want to move. Equal. There we go. Equal each other. If no number exists, that is a solution of the equation. That is a solution of the equation. We say that the equation has, as I said before, no solutions. This situation occurs when all the variables are eliminated and only two unequal numbers are left. And what I mean by unequal, right, because they're said equal to each other, right? So just two numbers that aren't the same. So if the left side is 2, The right side is any number but 2. Okay, and obviously there's an infinite amount of numbers it could be. And to conclude our 3-part series, a little roadmap for solving linear equations. I am not a fan of making this a robotic process because you still have to use this, right? You still have to rely on your intuition to inform you, right? I don't want to say you're always going to add or you're always going to subtract. Okay, those are only words I'll use, right? I'll say you'll always subtract if you're adding a term to the variable, right? There's always like these conditions. But breaking habits, right, and not perceiving mathematics to be this mechanized system is very important if you want to be successful, right? So first and foremost, okay, in terms of our roadmap, we would want to use the distributive property to remove any grouping symbols. Okay, grouping symbols allow us to start to combine terms and things of that nature. All right, we don't want to start grouping anything. Combining anything until we alleviate the grouping symbols. Okay, and then we can combine like terms on each. Okay, so we don't want to start pulling things over from one side of the equation to the next until we check the left side. Okay, left side, no like terms. Check the right side, no like terms. If there's like terms, you want to combine those first before you start moving things from one side of the equation to the other, because then it gets messy. Okay, and helpful hint, remember, when you're combining like terms, you can just go, right? Do the mathematics. Don't worry about applying opposite operations. Okay, only when you're combining like terms. And if you've done a unit on algebraic expressions and worked with polynomials, right, we never talked about using opposite operations. That's when we start to move things from one side of the equation to the other. So don't get them confused. Okay. Step 3, use properties of equality to get variable terms on one side of the equation and the numerical values. Actually, I'm going to change that. Let's use some more vocab. Oh no. Constants on the others. And constants are simply numbers set alone. +3, constant. -10, constant. +1 million, constant. As soon as a numerical value has a variable attached to it, 2x, it is now a variable term. Use the properties of equality to solve. I like to use the word isolate, but isolate wouldn't work in the sentence. Right? To solve for the variable, isolate. And then, as I said before in part 1, we can always check our solution by substituting our answer, x = 3, into the original equation and determining that it indeed creates the same value on the left and right side of the equation. Okay, but that'll do it. And as I've ended before on all my previous videos, if you have any further questions or want to provide any feedback, comments, comment below or send me an email. I hope this was informative and see you on the next round.